Okay, in this video we're going to be looking at expanding brackets involving surds. So there are two types of questions that you may come across. One of them is a single bracket expansion and the other is a double bracket expansion. The normal rules of surds apply and the normal rules of expanding brackets apply. So if we start with a single expansion, so something like root 3 bracket 2 plus root 6. Well, with this, both of the terms in the bracket need to be multiplied by the square root of 3. So we get the square root of 3 times 2, will be written as 2 root 3. And the square root of 3 times the positive root 6. So that's positive root 18. Now, square root of 3 can't be simplified, so this is still 2 root 3. But the square root of 18 can be simplified. So if you remember from the last video, I said when you simplify in surds, it's a good idea to have your square numbers written down somewhere. So if I write them here, 1, 4, 9, 16, 25, 36, and so on. And we're looking for the square number that's a factor of 18. So 9 is a square number, and 9 goes into 18 twice. So this can be rewritten as square root of 9 multiplied by the square root of 2. So this becomes 2 root 3 plus square root of 9 is 3. And 3 times root 2, so I get 3 root 2. Now because there's different numbers underneath the square root sign, then these surds can't be simplified any further. Okay, if I try and make a slightly more complicated question, so if we try 3 root 2 multiplied by root 5 minus 4 root 8. Okay, so both of the terms in the bracket need to be multiplied by 3 root 2. So if I start with the first term, 3 root 2 multiplied by root 5, well, the number part of it is just 3, and the square root is root 2 times root 5, which is root 10. And we're going to take away, because we've got a positive multiplied by a negative. So if I do the number part, 3 times 4 is 12, and the square root is root 2 multiplied by root 8, which is root 16. 10 doesn't have any square factors, so that stays at 3 root 10, but 16 is a square number itself, so the square root of 16 is 4, so that's minus 12 times 4, which is 48. And this is now simplified. So if I move on to double bracket expansion, so for example 2 plus square root of 5 multiplied by 5 minus root 20. So the normal rules for expanding brackets apply here in the same way. So both terms in the first bracket need to be multiplied by both terms in the second. So if I start with the 2 and expand this bracket by multiplying by the 2, I get 2 times 5 is 10. Then 2 times minus root 20 is minus 2 root 20. Then I move on to the root 5. So root 5 times 5 is 5 root 5. And root 5 times minus root 20 is minus root 100. So if I simplify this, I have 10 minus, okay, square root of 20. 20 has a factor of 4, which is a square number, so this can be rewritten as 2 lots of root 4 times root 5 plus 5 lots of root 5 minus, and the square root of 100 is 10. So we now have the 10 and the minus 10 will cancel. So we need to sort this little section out here. So, because the square root of 4 is 2, this is 2 times 2, which is 4, so we have minus 4 root 5 plus 5 root 5, which will give us 1 root 5, or root 5. If I take another example, so let's try 2 plus 5 root 3 multiplied by 4 minus root 12. So I start in the same way. I'm going to expand the second bracket by multiplying it by the first term here, 2. So I have 2 times 4 is 8. 2 times minus root 12 is minus 2 root 12. Then I move on to the second term, the 5 root 3. So 5 root 3 multiplied by 4 is 20 root 3. And then 5 root 3 times minus root 12, well, the number part is 5 times 1, which is, well, 5 times minus 1, which is minus 5. And root 3 times root 12 is root 36. Okay, so if I start simplifying my surds, so I have 8 minus, 12 has a factor of 4, so this can be written as 2 root 4 times root 3, because 4 times 3 is 12, plus 20 root 3 can't be simplified, 3 is a prime so it can't have a square factor, minus, the square root of 36 is 6, so this is 5 times 6, which is 30. So if I tidy this up, I have 8 take away 30 is minus 22, and then from here I have minus 2 times by 2, square root of 4 is 2, so that's minus 4 root 3, plus the 20 root 3. So if I collect together my surd terms, because I have the same number, they're both square root of 3, they can be collected together. I have minus 22, minus 4 plus 20 is plus 16 root 3. If I try one more example, I'll have 3 minus root 28 multiplied by 5 plus 2 root 7. Okay, if I do this expansion, I start the same way. I have 3 times 5 is 15. Then 3 times 2 root 7 is 6 root 7. Move on to the second. I have minus root 28 multiplied by 5 is minus 5 root 28. And then minus root 28 multiplied by 2 root 7. So I'm going to write this at the moment as 2 root 7 multiplied by root 28, and I'll come back to that in just a second. So come over here so I've got a little bit more room. If I start with the 15, nothing to be done there. 6 root 7, well, because 7 is a prime, I know there's no square numbers apart from 1 that will go into it. The next term, minus 5 root 28, well, root 28 is 4 times 7, so root 28 can be root 4 times root 7. Minus, now on this last one, I have my 2. I could do 7 times 28 and then end up with a large number which could be difficult to factorise. However, because I have a 7 here, root 7, and I know 28 has a factor of 7, if I rewrite 28 as root 7 times root 4, then the root 7 times the root 7 will cancel up the root. So this can be written as 2 root 7 multiplied by, well, root 28 is root 7 multiplied by root 4. So to neaten this up, I'll leave the 15 as it is for the time being, plus 6 root 7. Okay, this term, 5 times, well, root 4 is 2, so this is 5 times 2, which is 10 root 7. And on here, on the last one, the root 7 times the root 7 will give you root 49, or 7. So this is 2 times 7, which is 14. Root 4 is 2, so 14 times 2. Okay, so I'll just tidy this up again, because 14 times 2 is 28. And then we collect our like terms. So we have the number 15 take away 28 is minus 13. And the root 7 terms can come together. So positive 6 take away 10 is negative 4 root 7. And that's our bracket expansion.